Quite some time ago I posted a video on a repair I'd started on a Reperforator, and it's a very old machine. It's about 100 years old and it has various issues. It's essentially a glorified paper tape punch, but one of the issues I need to resolve before I can continue with the repair is to fix this part. It's, as you can see, broken. It should be in one piece. But this is basically aluminium. It's pot metal. It's not solid aluminium. It's very porous. It's saturated with oil and all sorts of contaminants, and it's got a very thin profile. You can see it's very thin walls, fairly complex shape. So repairing this will be a bit of a challenge. There are various methods you can use. You could make a backing block for it, that sort of thing. But this is visible on both sides when it's assembled. So I need to make this look fairly neat, and so what I've decided to do is weld this. Now, if you're not familiar with welding aluminium, it's an incredibly difficult material to weld, and especially this pot metal aluminium, which it wants to vaporize. It's also full of contaminants, so it's quite a challenge welding this. Now, I'm not going to show welding this particular component on video. It's too difficult a process to get the cameras in. I'm not even sure if I can video the welding process at all, but I will show you something similar, the method I use for setting up for doing this, and hopefully show you a bit of welding on that. And it's the same process, but we'll go over to the workshop and we'll get set up, and over the next couple of videos we'll try and repair this component. We're out in the workshop. Apologies if there's any flicker on the video. Not in my usual filming position, and the lights in here do seem to cause flicker, but hopefully it's not too bad and you can see what's going on. So this is what we're trying to repair in the next couple of videos. So as I said, this is kind of pot metal style aluminium, very porous, contaminated, but I'm going to try and weld it anyway. And welding aluminium is difficult at the best of times, but when the material's in this condition, it makes it even more difficult. Even more so on thin wall section material, and this will just blow away and vaporize within a second if you're not careful, and you'll just destroy the part. So you've got to be very careful. Also, you can't just go ahead and directly weld it. It's a bit of an odd process that you use. I'm going to be using a TIG welder, and the normal welding process is to start in one point and work your way along, adding filler material, and you end up with a weld. So something similar to this. You take two pieces of aluminium. This is one I just did a few minutes ago just to test the setup, and you can see that the process of TIG welding gives a very nice finish, very nice. Even on aluminium like this, it gives you a very nice finished result. But as I said, in solid metal like this, you'd start at one end and work your way along adding filler, as I did here, but that's not the process you use on material like this. I'll try and show it on video. I won't show repairing this, but the way I normally set up for this, we'll have a look at the Welder Set Up in a minute. But the first thing I do is try and set up the overall system, the overall method I'm going to use. And so I try to locate some scrap material that's similar to what I'm trying to repair, and is also similar in its physical attributes, its wall thickness, that sort of thing. Whenever I'm taking old machines apart or replacing parts, I tend to throw any useful material that I could use for that purpose into a bin and keep it for this process. So the first thing I do is select the TIG torch I'm going to use. I'll get this out of the way and we'll have a quick look at some TIG torches. I would say at this point I'm not a master welder, I'm not a welding expert, I'm just showing you the method I use. Whether it's good or bad, I'm more interested in the results. Other people will tell you there are better ways of doing it. So if you intend to give this a go and you haven't tried it, two things: it's not easy, it's much more difficult than it looks, and also there's lots of interesting videos on YouTube about this process, so I recommend you have a look at those first. So the start for me of the process in repairing is to select the TIG torch I'm going to use. So I'll get this out of the way and we'll have a look at some TIG torches. So when you buy a TIG welder, especially a cheap one, you'll get a torch like this. It may or may not have a switch on, and the switch is to turn the welding on and off. There are a couple of ways you can start a TIG welding process. There's no tungsten in this, we'll have a look at that in a minute. You can either do what's called lift start, which is where you touch the tungsten onto the base material and lift it, so it works a bit like a stick welder, and then the arc starts up. And the switch here just turns the welder on and off. It also turns on and off the gas. We use blanket gas for TIG welding. In my case, I nearly always use pure argon. A few exceptions, but mostly pure argon. And the switch, as well as turning the welder on, also opens the valve to let the gas flow out. And there's normally a cup on here that we'll again have a look at in a few minutes. And the problem with this type of TIG torch is it's got this big heavy umbilical. So you've got the hose for the gas, you've got the conductor for the current, and then you've got the wires for the control switch. And so it makes it, so even though it's got a pivot on here, it still makes it quite difficult. And because when you're TIG welding, you've got to keep the tip of the tungsten within about a 0.5 millimeter or millimeter of where you want it. Trying to maneuver this when it's got this big heavy umbilical can be a bit of a pain. You can do it, it's just not my preferred type of torch. So you can get different torch types and you can get different size torches. So this is a 26 size torch. It's good up to about 200 amps or so. Usually I'd use 2.4 millimeter tungstens in it. And I often modify them, so I've got a few of these that I've modified and I've taken off a lot of this excess. I use a foot pedal. I've never really used the switch, so I kind of remove all the wiring for that. And what I end up with is something that looks like this. So this is the cup I was talking about. There's lots of different styles and types. Although this has still got a switch on, it's not now connected to anything, I just have the hose. And it makes the whole thing far easier to manipulate. But fairly recently, last couple of years, I've moved away from this type of TIG torch. And the ones I prefer now are torches like this. It's much lighter, it's very flexible, it's got a much more flexible hose. And as I said, because I use a foot pedal, I don't need one with a switch on it. So the foot pedal will start the current, control the current, and also turn on the gas. I've also fairly recently moved over to these clear cups. It makes you can just see better what you're doing as opposed to the old style cups that you can't see through. You don't really look through the cup when you're welding, but it just gives more light and it just seems easier to see what's going on. Again, this is a 26 size torch, but for this particular job, because it's quite small and delicate, I'm going to use a smaller torch. So I'm going to use a 17 size torch, and you can kind of see the difference in the size if I put them side by side. And the 17 size torch is good for tungstens 1 millimeter to 1.6 or so, up to about 100, probably 120 amps, 150 amps, maybe if you really push it. But going that high, the torch will overheat fairly quickly. I only use gas-cooled torches, I don't use water-cooled torches. And I tend to only use the 17s up to about 100 amps. Anything above that, I'll go up to a 26. So as we carry out this process, as I say, I use the foot pedal and I'll be varying the current. It's not, I won't be setting the current at a certain level and then doing the process. It's a continuous, it's like driving a car, you're continuously jockeying with the foot pedal to keep the current exactly where it needs to be for the part of the process that you're carrying out. Now once I've got the torch selected and the tungsten, there's lots of different types of tungsten, and people will say, oh, you've got to use white tip, grey tip, green tip. I don't think whichever one you use is going to stop you welding. It's you can tell the difference when you're welding with them. But in all honesty, I found that it doesn't make that much difference, and you kind of just adapt to whatever tungsten's in there. Some types of tungsten will make it easier and will last longer, and will have less of a tendency to split and cause issues. But I generally use either white or green. I do mostly welding on aluminium, and sometimes I use grey, but they can be a bit of a pain. But as I say, in general, it doesn't make that much difference, and you just kind of adapt to whichever one you've got fitted. And the next thing I do is set up to just weld some aluminium that's a bit thinner than the cross section that I'll be actually working on. Different process, I'm just here dialing in the machine. So once I've done that, I'll find a bit of very similar material with a similar wall thickness, and I'm setting up here just to do a quick run and try and dial the machine in so I can weld and add filler along the top of a narrow section wall without blowing it all away. And once I know I can do that, then I'm getting fairly close to the setup I need for the actual job. And you can see here, hopefully, that I can add filler to the top without blowing away the material. And also you can kind of see the leading edge here. Hopefully there's this kind of weird white and then black area. This is where I'm cleaning, and I'll try and show that in the video. I don't know how successful it will be. I've never tried filming the welding process before, but it's a multi-pass process. Unlike welding clean metal, this is a multi-pass process that I'll try and demonstrate. So once I've got this working, what I'll do is I'll take something like this. This is just an old cast pot metal housing off an old fan, as you can see, and I'll just hit it with a hammer and break it into pieces. And I'll then try and re-weld it, and you'll see here that this section, a thin section, which is where it will break, is very similar to what we're trying to repair, and it's a very similar type of material. And what I'll then do is I'll try and weld it up, and this is one I did yesterday. Similar type of material. I broke this in half, and the porosity is not the weld, this is just the material. If you grind any part of this even before you break it, you'll get these little holes. As I say, this is very porous material. So I broke this, I re-welded it, and you can now obviously I've ground it, and now you can't even really feel the join. So if you were to paint this, rub it down, paint it, this would be pretty much an invisible repair. And it's also stronger now than the original material. It's no longer pot metal here, and if you break this, it almost certainly won't break through the weld. It will either break further up, or it will break where you kind of ended the weld. But I tried to bleed the weld well into both sides of the remaining material, so it kind of penetrates well into those areas. So the weld is actually quite wide and goes quite a long way into the base material. And as you can see, you end up with a repair that is, to all intents and purposes, invisible. So what we're going to do in this video is I'm going to cut this into 4 pieces, and we'll try and join it back together as we did with this. So I'll get it cut into pieces next. I've cut this into 2 pieces, and what we're going to do now is try to join this back up. And this represents the break in our part, and this is a similar type of repair. This is actually slightly thinner, so if we can weld this together, we should be able to repair the part. This is not quite as porous as the part we'll be trying to repair, but it is thinner, so it'll be fairly similar in terms of the overall process. So the next thing to do is get the welder set up. I've already set the welder up, obviously, when I was testing it for this, so we'll have a quick look at the settings. I'll explain briefly what each one is, but as I said, there are lots of videos on YouTube about TIG welding, so I won't go into too much detail. I'm not an expert on this, I'm just going to briefly explain what each of the settings does. So this is the welder I'm going to use for this particular job. I'm running pure argon through the torch. I've got it set to about 8 litres per minute. And as I say, I use a foot pedal, and the way the foot pedal works is when the pedal is off, the machine is not putting any current through the torch, and as you start to press the pedal, it turns the current on. And I use a high frequency start, and in that mode what it does is the welder will generate a high frequency and high voltage, and it will cause a spark to jump between the tip of the tungsten and the workpiece. That's not for welding, that's just to create a conductive path through the air that the main current can start up through. And then the main welding current will start, and the start high frequency will turn off. If it's spattering and spitting and popping, it probably means you haven't got enough current going through the main arc, and or you've got the gap too big. So I've got it set for high frequency start. I've got the current set, the peak current to 105 amps, so with the pedal fully down I'll get 105 amps peak, and if I have it halfway down I'll get about 50 amps. It's fairly linear, and the frequency I'm using, it's AC. We're welding aluminium, so we use AC current, and I've got this set to 120 Hertz, so I want good penetration, and so that seems to work fairly well for this type of job. We've got this what they call cleaning action, and that's the ratio of positive current to negative current. So in this case it's a percentage, so I've got it set to 28%, and depending on how much you want it to clean as opposed to how much you want it to weld, then you'd vary that value. It's not quite as simple as that, but it will vary the peak current and the cleaning action that you get from the welding process, and you need that for AC, or what happens is when you try to weld the aluminium, it immediately forms aluminium oxide, which melts at an extremely high temperature, and it kind of self-protects the workpiece and you can't weld it. And what the AC does is it welds a bit, reverses the current, blows away the contaminants, reverses, welds a bit, reverses again, and it just keeps cycling that process. And depending on what you set the cleaning action to, you can vary that action. And then we have the up and down slope time. I set these on 0. I wanted to start up immediately because I'm using the foot pedal, so there's no real value in me using those. They're only really that much value if you're using a torch that has a switch on it, so when you put the switch on, the ramp up and ramp down control how quickly the current comes up. But you can do that of course with the foot pedal. And so that is basically how I've got the machine set up. There are a couple of other settings on here that you don't really need to be too concerned with. It's mainly the peak current, frequency, and the cleaning action that are going to be the most important things to set. None of these are really going to make a massive difference if you make small adjustments. So for example, if we take the cleaning action and we turn it from 28 to 25, it's not going to make that big a difference. You'd probably just adapt your welding to suit, and you're just trying to get something that's kind of in the ballpark of being correct. And if it's a long way out, then you will struggle to weld. But that's what the test pieces are for, is to get this dialed in somewhere fairly close. Now in reality, of course, I didn't really adjust this for this particular job. I've got various settings saved to memory, but I just thought I'd go through what these settings are in case you were interested. We've got the control down at the bottom which plugs into the foot pedal. We'll have a quick look at the foot pedal. So we've got the foot pedal sitting by the side of the bench, and you just stick your foot on there like a car accelerator, and that controls the current, and it also turns the weld on and off along with the gas. So the next thing is to set the job up on the welding table. It's just a slab of mild steel, and normally I would clamp this down, but if I put the clamps on you won't be able to see anything at all, so I'm just going to try and rest it on here and hope it doesn't move around too much. But really you must have it clamped down, otherwise you're in danger of it moving around or not being in good contact with the table, so it might disrupt the welding in this case. But this is for demonstration only, so it's more important that you can see what's going on. What I'm going to do is try to film this. I don't know if it will come out, I don't know how well this camera will respond. I'm going to put the camera inside a spare welding helmet. If I just try and video directly at the weld, it will probably damage the camera, so I don't know quite how much you'll be able to see. I'm also going to point a camera at the welder. It shows the current as and voltage as I weld. I'm not quite sure what it's going to show. I've never actually tried doing that before, but you should see the current varying as I modulate the pedal to adjust the current as I proceed with the weld. So hopefully you'll be able to see what's going on. So I'll get this set up now, ready for welding. I'll get the camera set up and then we'll give this a go and see if we can actually get it welded back together. Okay, so that's the inside done, so not pretty. The idea of this is to try and get it to hold together. I can't really see what I'm doing, the camera's in the way, so it's making this extremely tricky, but you get the general idea. What I'm trying to do is make sure I get good penetration down into the base metal. Now, normally what you do before you start welding is use a carbide burr or something to remove some of the material from the weld area. But because this metal is so porous, I don't need to do that because I clean it up. I actually form the channel I need to put some filler in. So there's quite a lot of filler in this now. If that's too much, it's sticking right around. We can grind that back later. But I want to leave it cloud now for a couple of reasons. One is to give it plenty of support while we turn it over and weld the other side. But also it will give it much more thermal mass. So this base metal is very porous, it's got very low thermal mass, and it's got a tendency to pop and spit and whatever. But now it's got some real material behind it. In theory, we should be able to weld and hopefully not blow through it. Now it's fairly safe this way because it's sitting on the cold welding table. When I turn it over, it's a very thin section, and if you're not really careful, it will just blow a hole straight through it. So I turn this over, we'll try and weld the other side and see how successful we are. Okay, so I've ground the inside. One thing I didn't mention on this particular part, there's this little step that we want to retain. Now this of course is just a test piece, so I didn't bother going right up to the edges, but what you would normally do at this point is go back any small voids, such as these at the end, you'd fill in with weld, and basically just continue this weld across to fill in and put plenty of material on here. You may have noticed during the process I stopped a couple of times, and that was just to let the part cool down. If we get it too hot, it will either sag or blow through completely, so it's just to let the heat dissipate a little bit and avoid getting too hot. But what we're trying to achieve here is a continuous weld, and then, as I say, at this point you'd normally go back, finish filling in any voids, and then we can take it away and finish the grind process. But this is just a test piece, so I'm not going to do that. I'm just trying to get the process settings right to make sure that it's successfully welding all the way through. So I'm going to go and grind this area away now and make sure that the weld has penetrated all the way through the material, and if it has, we can then move on in the next video to repairing the actual part. So after grinding, this is how it looks. Now, as I said, you could go back and touch up the gaps before you grind, as I did with this one, and that way you get nice square edges. But as I said, this is just a test piece. What I'm trying to get across here is that the finished join, where you've finished and completely welded, should be pretty much invisible. There is a slight difference in the general colour of the metal where the fillet is, because it is of course now solid aluminium rather than this porous material. And just as a final step, what I'll do is just put some undercoat on this, because it's probably quite hard to see the finish, but the idea is that once you've welded and ground, when you paint it, this should be an invisible join. We're trying to make sure we can't see this at all. It's one of the reasons I left these little parts at the end, so you'll still be able to see where the cut was, but the parts in between should be pretty much invisible as far as the repair is concerned. Okay, well, excuse the poor paint job. I didn't bother cleaning this very well. I just sprayed some undercoat and top coat on it, so it's a bit speckled, but hopefully you can see that there is no sign whatsoever where the actual repair is. You can still see where the cut was with the two notches, but hopefully you can see that between there is absolutely no sign that this was ever repaired. And if you'd carried the repair and the weld right to the edges and then ground them square, and that would be pretty much a totally invisible repair. You'd never know it's been done, and it is also now stronger than it was originally, so it's a good repair technique. Now, it does take practice. It's not necessarily as easy as it might first appear, but TIG welding in itself is something that's a lot of fun, and it's well worth learning to do, just if you're interested in engineering. It's quite an interesting process. But for things like this, as you can hopefully now see, it's an incredibly good technique to use for these repairs. So if we can get this type of finish on our perforator part, then it should be an invisible and strong, long-lasting repair. So that's what we'll do in the next video. Unfortunately, I won't be able to show you the welding in the next video. It's almost impossible to weld, as you probably saw in this video, because I can't get proper access to the joints. Even so, it's come out reasonably well, but I don't want to risk damaging the part by not having good access to it. So I'll show you the individual steps, but I won't be able to show you the actual welding itself.